Ready-made maths, YouTube teacher training videos. Today we're on day 8 and this is part 2. Hopefully you're only watching this video if you have watched part 1. This is teaching assistant and teacher training in mental mathematics. In part 1 of today we looked at adding consecutive numbers, just relatively short strings of numbers and how we can add those really quickly. In part 2 what we're going to do is take that a lot further and into much more greater depth. We're going to meet a gentleman named Carl Gauss and how he came up with a very good strategy for adding any string of numbers, no matter how long it is. So I hope you find this an enjoyable session and get to grips with some greater depth strategies for adding long strings of numbers. Right, now we've got a second little tip for strings of numbers now, but this is when you're getting a much larger amount, 20 consecutive numbers or 50 consecutive numbers and so on. And to do that, we're going to go and meet a gentleman, or at the time, a child called Gauss. Carl Gauss is a very famous Swiss mathematician who's basically responsible for a lot of the higher level mathematics that people study now at a much higher level. But when Gauss was a young child, he did come up with a really nice strategy that we're going to share with you.
A little bit of literacy now, it's story time. This is a real story, completely true, and this is about a famous mathematician called Carl Gauss. Now, when Carl Gauss was, I think he was about 7 years old, he was so far ahead of the rest of the children in his class that the basic teacher had no idea what to set him to do when everybody else was doing very basic, two-digit number work and so on. And so while she was teaching basic, calculation strategies to the rest of the class, she thought she'd come up with something that she thought would keep Carl Gauss busy for the rest of the lesson. So they were doing adding two numbers up. And what she said was, imagine, Carl, that you've got all of the numbers from 1 to 100. Every single one. 1 plus 2 plus 3 plus 4, all the way to 100. What I want you to do is I'd like you to work out the total of all of those numbers. Off you go, Carl, and I'll see you at the end of the lesson. Anyway, what we're actually looking at here is, if we look at this board, you can actually see a visual of what the total of all the numbers from 1 to 100 would look like if we were to add together every single individual one that's on there, the tens and the ones, and adding them all together, what would the total be? Anyway, what happened was she then went to the front of the class and started to teach the rest of the class. Probably within about a minute, his hand went up and he said, "Miss, I've got the right answer." Now, obviously she'd worked it out beforehand because she needed to make sure it was the right answer. She went over and looked, and probably in around about 30 seconds to a minute, Carl Gauss had worked out the total of all the numbers from 1 to 100. Now, it was nothing to do with consecutive numbers, like we were looking at before. It's an even number of numbers anyway. Carl had done something completely different. Now, I'm not going to ask you to try and be Carl Gauss, but what would be really interesting would be just pause the video completely in a second, get some pencil and paper out. If you've got 100 square, even better, get yourself 100 square out because you can see all the numbers that you're looking at. Because whenever I do this in class, usually in year 5 or 6, but it can be done. I know some schools do teach this in year 4 as well. It's really nice to actually have a visual 100 square in front of you so you can cross the numbers off as you're using them. I'd just like to think, is there an easy way of finding the total of all the numbers from 1 to 100? Can I break it down into little sections and put them together? Or can I find a little trick that might help me? We'll have a look, and then probably we'll get back together. I'll probably move away from the classroom then, and we'll have a look on the PowerPoint presentation at some of the little patterns that we could put together. And I'll also just give you just a few little tips and tricks that might work. And then we'll see what did Gauss do and how did he work out the answer so quickly. One really interesting way of starting the Gauss problem is just to start off with the numbers 1 to 10 and think, right, let's not try all the way to 100 yet. Let's just get all the numbers from 1 to 10. Now, we could number bond them, we could add them all up, but we now know a new strategy. Let's just get rid of the number 10 for the time being. And we've got the numbers from 1 to 9. What's our current strategy? That's 9 consecutive numbers, so we take the middle number and multiply by 9. 5 times 9 is 45, and add that 10 to get us to 55. Another way of doing it would have been number bonds. 10, 20, 30, 40, 50, 5. And another way would just have been to take this number and this number, 10 and 1, which makes 11, 11, 22, 33, 44, 55, because all of those different numbers add up to pairs of 11. So there's lots of different ways to get there. Eventually, we'll get the total 55. The problem is, I don't want to have to keep doing this for every single set of numbers all the way to 100. So I need to find a little bit of reasoning, something that's going to help me. This wasn't what Gauss did, but this is what a lot of children do when they look at the next line. Right, I've got to add up 11 to 20. How am I going to do that quickly? I can't do all that in my head. Wait a minute. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's a 10 within there. Well, that's what we've had up there. We've actually got all the numbers from 1 to 10, but they're all 10 more. That's 10 more than 1, that's 10 more than 2, that's 10 more than 3. So actually, we know that 1 to 10 is 55, and each of these is 10 more. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. It's got to be 155, because each of the numbers here is 10 more than the number above it. Well, that must mean the numbers 21 to 30. Well, 21 is 20 more than 1. 22 is 20 more than 2. So it's actually 20 more. So that's going to be 20 multiplied by 10. That's going to be 255. In fact, each line is 100 more than the line above it. If you've got 100 square, you can check that really easily. 31 to 40 must be 355. 41 to 50 must be 455. 555, 655, 755, 855, and finally 955. Now that was definitely not what Gauss did. That would have taken quite a long time to do. We can't work out the answer. We've got 10 lots of 55 there. 6, 7, 8, 9, 10. So 10 to 55 multiplied by 10 equals 550. And then we've got all these different hundreds. Well, we've got 900 and 100 is 1,000. 800 and 200 is 2,000. 3,000, 4,000, and 500. So 550, 4,500, add them together, and you get 5,050. So that's the actual answer, but that's not what Gauss did. There's other strategies we could have used as well. That's a really nice one to do with children though, because it's very structured, it allows them to reason, it lets them get the answer. You don't have to start all the way from 1 to 100, just start with 1 to 50 or 1 to 40 and build it up from there. But that's a really nice way to get the answer. As I said, what we're going to do now is have a little play around back on the PowerPoint with Gauss himself. We'll work out what he did, and then we'll look at how that strategy can then be employed for any set of numbers from 1 to whatever, and we'll be able to use that as a little mathematical trick as well.
So you've now had a go at the problem that was set for Gauss when he was 7 years old. How did you find the sum of all the numbers from 1 to 100? What strategies did you use? What recording methods did you have? Did you use 100 squared? Did you just write them all down? What did you use? How might you start this activity with a group of children? If I'm doing this, probably don't start with in year 4 with numbers from 1 to 100. I might just start with numbers 1 to 20 and build it up from there. Or even build up from 1 to 10 to 1 to 20, 1 to 30, and then go all the way to 100. With year 5, 6, and certainly year 6, I do start with the 100 and then backtrack. And how could you develop this activity further? This is what we're going to be looking at in a second. Now, as we just saw in the classroom, there's quite a nice little way of using the 100 square. I've just highlighted a few rows for you there. We can get the total for the top row of 55 by just finding bonds to 10, as we've shown, or doing 11 multiplied by 5, because there's 5 lots of 11 there. Or, as we now know, say 6 add 5, 11 in the middle, and make it 5 times bigger. But the most important thing is we see this connection between the 1 and the 11, the 2 and the 12, the 3 and the 13. Each number on the second row is 10 more than each number on the top row. Therefore, 10 tens are 100. The answer, therefore, must be 155. As we look at the next one, 2 options. Either 21 is 20 more than 1, or 21 is 10 more than 11. So basically, the next row is 10 more per number than the previous row. Again, 10 tens are 100, so this row must be 100 bigger than this row, or it must be 200 bigger than the top row. That gives us 255. We looked at all that downstairs, we add them all together. What we actually end up with, I've tried to colour code it for you, are 10 55s, 55 multiplied by 10, and then I've colour coded the thousands. There are 4 thousands and an extra 500. So 4,500 And 550 gives us that total. There are other ways of doing it though. Often when I set this in class, people don't start off by adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They often start off possibly by adding that first row, that first column. Other people go all the way to the end. Because it's multiples of 10, it's a little bit easier, and so they actually add together this particular column. Now, if you add this column together, there's 100, 90 and 10 makes another 100, 20 and 80 makes another 100, so we're now into 100, 200, 300, 70 and 30, 400, 60 and 40, 500, and then we've got a 50 there, 550, and that gives you that total down here. Alternatively, if you have the first row up, you will get basically, again, you've got 90 and 10, 80 and 20, 70 and 30, 60 and 40. So you've got 100, 200, 300, 400. And 50 is 450. And then you've got your ones, 10 ones. And that gives you a total of 460. So whichever way you've done it, we'll start at this end. If we're using our reasoning, if that column adds to 460, every single number in this column, is one more than the previous number. So 52 is one more than 51, 62 is one more than 61, and so on. It must be overall 10 more than this column. It's got to be, because each of the numbers is one more, and there's 10 numbers. So that must be worth 470, 480, and so on. In the end, you get the numbers you have along the bottom from 460 to 550. If you add all those up, I'll just show you a quick way. You've got 1, 2, 3, 4, 5, 6 500s, which you can see up here is 3,000. You've got 1, 2, 3, 4 400s, which is 1,600. And then what you've got left is basically 60 and 40, 70 and 30, 80 and 20, 90 and 10. So again, you've got 400, and the 50 at the end gives you 450. Add all those things together, you still get the total 5,050. Not the quickest way by any means, but it's a way that some children and some adults work it out. As we mentioned downstairs, that is not what Gauss did, and it might not be what you did either. Did you start with the numbers from 1 to 10, or start with the first column, or did you pair numbers up? Now, that's where Gauss kind of comes in, when you pair numbers up. And actually, quite a few people do see elements of this. I'm going to take you back to the 100 square. If you pair numbers up, how many pairs do you make, and what does each pair add up to? And do you need to add anything else? Let's have a look. What I've tried to do is highlight there what a lot of people do, because it's much easier if you've got pairs of numbers. So if I've got pairs of numbers, well, I've got 99 add 1 makes 100. I've got 98 add 2, 97 add 3, 96 add 4, and so on. You're actually going to have lots and lots of pairs to 100. Now, a lot of people do make a mistake here and say, well, actually, it's 50 pairs of 100. It's not 50 pairs, because you've got 100 on its own here, and you've got the number 50 here, which doesn't have a partner. So it's actually 49 pairs of 100. So how many pairs are there? There's 49 pairs. And then you've got to add on at the end the 100 and the 50. So how many pairs to 100? 49. So that's how many you've got. What's left to add? Another 100 and the 50. So that's how we get that one. What Gauss did was went one stage further. At 7 years old, he looked at it and did it this way. He didn't make pairs to 100. He looked at it and just said, right, I'll split the grid in half. There must be 50 pairs. And if you look at the first number, 100, so 1, and the last number, 100, they add together to make 101. You've then got 99 and 2, 98 and 3, and so on. This way, every number's got a partner. 50, we'll go with 51 to make 101. 52, we'll go with 49. This time, you're going to end up with 50 pairs of 101. So the Gauss problem shows us we've got two options. We either pair them up to 100, 49 pairs of 100 plus 150, which gives us 5,050, or we can do what Gauss did. He didn't add up to 100, he added up to 101, and there were just 50 pairs. That's everything covered. 50 pairs of 101, 50 times 100 is 5,000, 50 times 1 is 50, add them together, 5,050. Although the first one's easier because it's pairs to 100, the second one is basically a generalization, and that will work with any string of numbers. So what's the total of all the numbers from 1 to 100? There's 50 pairs of 101. can we apply that now with lots and lots of different numbers? Just to finish off this little bit of playing around with Gauss, we're going to use that same principle and work out the sum of the numbers from 1 to 8 and the sum of the numbers from 1 to 12. All you need to do for the time being is just write those down. Write 1 to 8 down, write 1 to 12 down, and see if you can work out what do you think Gauss would have done. Once you've worked that out, apply it to those numbers, and then try it with 1 to 20. Leave the other three at the bottom, just for the first three, 1 to 8, 1 to 12, and 1 to 20. Let's just pause the video while you look at those. So how do we find the sum of the numbers from 1 to 8? Quite simply, 1, 2, 3, 4, 5, 6, 7, 8. Well, that must be 4 pairs of numbers because there's 8 numbers altogether. And what's each of the pairs add up to? Each of the pairs adds up to 9. 8 and 1, 7 and 2, 6 and 3, and 5 and 4. So you end up with 9 multiplied by 4. If we're looking at all of the numbers from 1 to 12, first of all, how many pairs are there? Well, there's going to be 6 pairs, but what are they going to add up to? Well, they're going to add up to 12 and 1, because it's going to be 12 and 1 is 13, 11 and 2 is 13, 10 and 3, 9 and 4, 8 and 5, and 7 and 6. You can prove that just by writing them out. The quick way to do it is, right, so 12 and 1 is 13, and there's going to be 6 pairs. So 13 multiplied by 6 is 78. Let's apply that to these numbers. First of all, what are they going to add up to? Well, they're bound to add up to 21 because it's 20 and 1, or 19 and 2, or 18 and 3. How many pairs? Well, there's 20 numbers, so there must be 10 pairs. But all we're doing really is halving each of these and then multiplying by these. So 21 times 10 gives us a product of 210. Let's now spend a bit of time. If you don't need to do these. If these are a bit more complex, don't worry about it. But if you do want to have a little play, just try and work out what the total might be for 1 to 50, 1 to 200, and 1 to 1,000. 1 to 200 is probably the easiest of the three. Let's just pause the video. So for 1 to 50, well, the pairs are going to add up to 51, and there's going to be 25 of them. Half of 50 is 25. 25 pairs, and we end up with 51 multiplied by 25. If you want a quick way to do that, I would do 51 times 100, and then half it twice. So 5,100 halved, and then halved again. One way of doing it. What's the sum of the numbers from 1 to 200? Well, there's going to be 100 pairs, and those 100 pairs are all going to add up to 201. 201 multiplied by 100, 20,100. And last but not least, bit of a hard one, but it definitely works. What's the sum of the numbers from 1 to 1,000? Imagine all the numbers from 1 to 1,000 together. What's the total? Well, how many pairs will there be? 500. And each of those will add up to 1,001. 1,001 times 500. Well, 1,000 times 500 is 500,000. And 1 times 500 is 500. So we end up with 500,500. In real life, this is very, very unlikely. You're never going to be asked to work out these later ones, but you may well at some point have to find simple totals, all the numbers from 1 to 8, 1 to 12, or 1 to 20. And you've got a nice, easy strategy that works there. It's like the consecutive numbers one, but taken to the next level. So finally, what is the sum of the numbers from 1 to any number? Well, as a general rule, you add the first and the last number, and you multiply by half of the last number. That's just the general strategy that works. There is an alternative way if you want to go into algebra. I will just leave that there for you to look at in your own time. I'm not really covering algebra in these sessions. If you do want to look at it, that's another alternative formula. The one that we're using, though, is this one. First add last, multiply by half of the last number.
Fantastic. So, having had a little look at what Carl Gauss did, which is unbelievable for a 7-year-old, what we're now going to do is we're going to look at the final trick of the day. This is a much, much quicker one than the previous two. This is probably aimed at year 2, 3 initially, and then can be built up to other age groups. It's quite simply, how do I get my number bonds to multiples of 100 or multiples of 1,000 and so on. So if I was to start off with 1,000, I often say to children, find me the number bond that makes 1,000. Well, 900, they know, goes with 100. We've done that one before. 700 goes with 300. We're used to that. 7 and 3 is 10. 70 and 30 is 100. 700 and 300 is 1,000. What we then build up to then is, well, can you find me other numbers that make 1,000 that aren't multiples of 100? So children come up with things like 950 add 50 and 999 add 1 and things like that. Now that's obviously really easy ones they can work out themselves. What we're going to look at is just how can we find any pair of numbers to 1,000 where it's just a random 3-digit number. So I'm just going to roll one. I'm going to roll a 3-digit number. There's my hundreds, there's my tens, and there's my ones. So got my 3 dice. Put these out of the way now. I don't need these anymore from before. I'm just going to roll my dice. And I've rolled, always does that, I've rolled 563. So we'll leave that one there. I'm going to write that one down on the board. 563. Add blank, blank, blank equals 1,000. Right, I'm going to come back to the dice again. I want to roll another. If I want to roll some different dice, I'll roll the same ones. I'll roll 3 more times. I'll write the numbers on here. 728. So 728. I'm going to roll this one. I've got, that's a 0, so I'll roll that. So 700 again. Next time it's not set that. 594. Okay, so 594. And my final set of numbers is 459. 459. You might well know this little trick. It's probably the easiest one of the 3 that we've looked at today. I'll write these numbers on the board. So 728, add something, 594. Add something, and 459. Add something. Now, in tomorrow's lesson, we're going to be looking at lots of ways to actually make number bonds visually and to learn number bonds. So we'll take this strategy and backtrack and show where it comes from with 2-digit numbers and single-digit numbers. Now I'm just going to give you a few seconds to have a look at that, a little bit of a challenge for you. Can you work out the number bond to 1,000 for each of those? Number 1, how do you work it out? Number 2, do you have a little quick strategy that works every time? If not, we'll have a quick look in a second. We'll just pause on the video, have a look at those numbers. What I'm now going to do is just work out the answer really quickly. So 563 add 437 equals 1,000. 728 add 272 equals 1,000. 594 add 406 equals 1,000. And 459 add 541 equals 1,000. What did I do to get the answer so quickly to those calculations? I wonder if you actually spotted the little trick that happened here. I think the easiest way to spot it is to actually set them out vertically. First vertical calculations we've done all this time. I'm not actually going to work the calculations out. We're just going to look at the number pairs in the hundreds. 4 and 5, 5 and 4, 7 and 2, and 5 and 4 again. What's the connection between those? They all add up to 9, or 900. Look at the tens. 5 and 4 again, 6 and 3, 2 and 7, and 9 and 0. Again, the connection's the same. They all add up to 9. We have a 900, and we have 9 tens, or 90. Slightly different in the ones. 9 and 1 is 10, 7 and 3 is 10, 8 and 2 is 10, and 4 and 6 is 10. So rather than actually looking at just a random arrangement of numbers, what we're looking at is 900, add 90, which is 990, add 10, which makes 1,000. What I've done is I've represented 2 of those calculations over here with place value counters. You can see again, set out in that arrangement, we looked at all last week, 563 and 437. If I was to put those tens up here, we can see we've got 9 tens, put the hundreds all together up here, we've got 9 hundreds, and again, put the ones all together. What we've got now, 9 hundreds, 9 tens, 10 ones, 10 ones is equal to a 10, so therefore that's why we've got 900. We've now got 10 tens, 10 tens is equal to 100, and obviously 10 hundreds is equal to 1,000. Looking at the second example, 728 added to 272. Again, you can see the layout of the tens in the 5 and a bit example. We've got the 700 and the 200, gives us 900. The 7 tens and the 2 tens gives us 9 tens, or 90. And the 8 ones and the 2 ones, again, gives us 10 ones, or a 10. 10 ones exchange for a 10. 10 tens exchange for 100, and then 10 hundreds make 1,000. Exactly the same. Really nice trick to know. That's as far as we're going to be going with that one. But tomorrow, what we're going to be actually doing is looking at loads of work on number bonds. We'll come back to this and we're going to look at lots of really fun activities to help us learn and remember them as well. So that's the end of today's little tips and tricks day. I hope you've enjoyed it. It's been a little bit different to the other days. So trick number one we looked at was consecutive numbers. 3 consecutive numbers, multiply the middle number by 3. 5 consecutive numbers, multiply the middle number by 5. Again, works for any sets of odd consecutive numbers. You'll also have seen the little examples that we did on the PowerPoint presentation with 4 consecutive numbers and with 6. So you can see there's always something we can do. There's always a trick. There's always an easy way. We never have to go the long-winded way. We can always find a trick or a reason to do it a little bit simpler. The second trick was the Gauss one. If we've got the numbers 1 to 10, we find half of that, which is 5, and we multiply by the first and last number. 1 and 10 is 11, and 11 times 5 is 55. If it's the numbers 1 to 20, we've got 10 pairs of 21. If it's the numbers 1 to 100, as Gauss came up with, we've got 50 pairs of 101. If it's the number 1 to 16, we've got 8 pairs of 17. Great little strategy, just one to remember it. You may or may not use it, but again, nice to know. And the final little trick, pairs to 100, pairs to 1,000. 990 and 10, or 9910. Just makes it so easy to pair up any pair of numbers to get a total of 1,000. That's it for today. As I said, tomorrow is number bonds. That's it, just number bonds for the whole session. Games, songs, just fun little activities. So by the end of tomorrow's session, you've come up with loads of ways that children, predominantly in Key Stage 1, because today was very much a Key Stage 2 day, tomorrow's very much a Key Stage 1 day. How can children in Key Stage 1 learn, recall, remember, and visualise what number bonds look like? Thank you very much, and I look forward to seeing you again tomorrow.
And that's it for today. Completely different day to the previous ones. Today has been about tips and tricks. Probably a little bit more advanced than some of the other days because we haven't gone into reasoning and applying rules and so on. But if we just take it at the basic level of adding consecutive numbers and adding strings of numbers, it's a strategy that can be used really effectively. It's also a great one to do with children once they've got MC, wrapper code, and number established. I probably wouldn't move on to these little tricks and tips until I know we've got a bank of calculation strategies, a repertoire that's being used a lot, that you yourself are using them as well. Anyone that's working with children is starting to use mental calculation strategies. And then we've got these couple that really add to it. I would probably do the consecutive numbers as an introductory lesson, as a reasoning lesson, and then just constantly bring it back. And what's 9, 10, and 11? 30, brilliant. What's 14 add 15 add 16? 45. The other one, Gauss, is probably more of a kind of almost a one-off lesson. And I'd tell the whole story. I'd play the part of Gauss. I'd turn it into a proper story of the whole thing. And I've made that a one-off lesson where you learn and practice the Gaussian strategies. That one you won't use in everyday life anywhere near as much as the consecutive numbers. The final one, number bonds, is used all the time. It's the most common one, the most common strategies you'll use. And you can then apply that to number bonds to 100, decimal numbers, and basically pretty much any number bonds to multiples of 10. Thanks for following today's teaching, and I'll see you all tomorrow for a much more kind of practical day where we're going to be looking at number bonds in many different ways. See you all tomorrow, and thank you very much for joining me.